Guys, welcome back to the RPG game series. In this video, we're going to be adding a basic movement system. If you double tap W, you can run like this, and there's also a jump cooldown. You can also dash in any direction, as you can see. And if you side dash, you can actually change the direction, which is pretty awesome. This, yeah, it's pretty awesome. Okay, so I wanted to add in climb and sliding in this video, but they're actually really complicated, so I think they deserve their own dedicated video. Like I saw a tutorial on that on sliding, and the guy used Raycast hitbox and he modified that shit, man. Like, come on, bro. That video was like 1 hour long. It's insane. Shout out to him. I forgot his name. But first, let's go to combat input. Let's make the jump cooldown. It's pretty simple. There you go. Let's do humanoid jumping. So this event runs whenever you jumped. Okay, which is pretty simple. And there's a default parameter in this function, which is jump. So if you jumped, then it's true. If you don't, then it's not going to be true. And so when you jump, we're going to disable jumping by doing humanoid set state enabled jumping to false. So this can set a state. So this method can disable or enable a state. The first parameter is the state. The second parameter is the boolean. If you want it to be enabled, you say true. If you want it to be disabled, you type in false. So I want my jump cooldown to be 1 second. I set it to false, and then I set it back to true. And then we add in running, okay? So here, we don't have movement module right now. So you can comment that out. So I'm gonna comment that out. There we go. So here, what I want to do is when I double tap W, you run. And if you press block or if you press M1, it disables the running. It automatically walks. So there's going to be a disable run and an enable run in my function. But first, let's make the double tap W thing. Okay, so here let's add in an else if enum.keycode equals keycode equals W. We add in new variables max run tick, which means and run tick. So what we're doing is we're trying to find the time spent between the last time we pressed W and now. So here, if we press W, we get the tick minus run tick, which is already defaulted to tick, which exists when your character gets added into the game. And when you do this, you get the time spent between the first time you press W and now. So let's say it's been 1 second since you've pressed W. And then it's going to compare it to max run tick, which is 0.2. So if it took you 1 second to press W again, then you won't run because that number is bigger than 0.2. So what we want is that the player has to press W twice within this 0.2 second window. Okay, if it is, then we set running to true, which is a variable, and then we reset the run tick so that the user can run again. And if not, we can reset the run tick as well. And then if we press Q, if key code equals Q, then we enable movement.dash with humanoid.moveDirection as its parameter. So humanoid has a property, it's called move direction. It's the direction where the player is walking towards. Okay, so let's make the movement module. So in replicated storage in client systems, let's make a new folder for movement system, and let's add in a module script movement module. Here let's add in the basic variables: run service, player, camera, and this is the default. We get the profiles client if you need to. So if you want to change the animation depending on your weapon or your class, you can do that by doing a basic if statement in the run. So you can just do if profile client data dot something something equal to something, then change the animation equals game replicated storage something. It's pretty simple actually. It's pretty simple. I don't need to really explain it that much. And then there's also the variables for the configuration: the base speed, which is the default humanoid walk speed; the dash force, which is how fast to dash; the dash duration, how long the dash lasts; the dash cooldown, the cooldown between dashes; and the can dash, which is whether you can dash or not. Here are the animations. You can here's in replicated storage there's animations. You put in your own animation, and run animation is a default state, is an empty variable in which you can play or stop if it exists, in which you can stop the animation if it exists. So I'll go into dashing later. For now, let's go into running. We get the character, we get the humanoid, we check if the character is stunned or end lag or blocking. If so, then return end. And then there's the toggle, which is true or false. If it's false, then we set the humanoid walk speed to base speed. If run animation exists, we stop it, and then we return so that the script no longer continues. But if the user is running, then we load the animation, we play the animation, we set the default base speed, we set the base speed to humanoid walk speed. That's because maybe you have an ability to make your base speed faster, so therefore run has to be faster than that instead of the static value. So let's say you have an ability like lightning cloak, your base speed becomes 20. It wouldn't make sense if the run speed is 19. It wouldn't make sense. So it has to be higher than the base speed. That's why we increment the walk speed with 7. And if we stop running, we set the human walk speed back to base speed. I'm pretty sure there's a better way to do base speed, but this is my way. If I notice anything wrong, if you notice anything wrong, you can comment down below just to let me know. So yeah, once you've made that, you can uncomment the run. And then to disable the running, we do task.spawn heartbeat, run service heartbeat connect function. So we can't just do, so this is how we detect when the character stops moving. If magnitude is 0, is bigger than 0, then the player is moving. Else, the player stops moving, then we set running to false, and movement module.run equals false, and movement module.run false to disable the running. We do if running first so that we don't call this every time we stop moving, so it's more efficient. So the reason why we do this, instead of just doing user input service input ended and using key code W, if stop pressing W, then we stop running, then we can't do running in multiple angles. If we do that method, then it stops running right here. I'll show you. Oops, not this. If input of key code enum.keycode.w, then let's do this. we move right, it stops running. See? We don't want that. We want it so that we can keep running in every direction. Let's remove that. Now let's make the dash. So here if you press F, you set run to false. If you M1, you set run to false. Now let's go into the dashing, which is Q. And then let's make a dash function with move direction as its parameter. We get the character, humanoid, and root path as usual. We get the stand, attacking, and leg blocking values. Now we make new variables. The connection, which is for a connection that we're going to disconnect, and the direction, which is the angle in which the angle the camera is looking at. So we do a check here. If attacking and like stand blocking, then we can't dash. And if we can't dash, then we can't dash. Okay. Here it's basically a debounce variable. After that we set can't dash to false so that we can no longer spam dash. And the reason why we do this, it's important that we do this after we do this check. Because if we set can dash before, then in the script we're not going to be then in the script if we set can dash equals false before any of this, then can dash won't ever be set to true. So yeah, it's important to do this before can dash equals false. And it's important to do this before can dash equals false also. And then we check the move direction magnitude. If it's 0, that means the character isn't moving, and we have to add in a default value, which is root parts cframe.loop vector multiplied by -1. It's a fallback. So if the character isn't moving, then if you press Q, it'll move backwards, like in debuggen. And then we get the forward and right vector. I don't think it's new. And then we get the forward and right vector. Forward is root part.cframe.loop vector. The root parts forward, okay, right, root parts right vector. It's self-explanatory. And then here we want it so that we change the animation depending on where the character is moving, and the angle too, to where the character is moving. We need the angle so that we can change the direction for the side dashes midway. So how do we do that? By doing forward dot. What's dot? So dot is basically comparing this direction to this direction. If they're facing the same direction, then the dot value is 1. If they're somewhat different but still the same, it's 0.9. It's a range. So it compares vector 3. As you can see, that it sees how much two vectors go in the same direction. If they're in the same direction, it's going to be 1. If they're in complete opposite, it's going to be -1, not 0, my bad. If they're facing at a right angle, then it's going to be 0. If it's almost equal, then it's going to be 0.9, 0.8, 0.7, stuff like that. So that's why we check if it's bigger than 0.7, forward dot, to see if it's looking forwards. If it's not, if it's smaller than -7, then it's looking backwards. Use the same logic for right dot, for right and left. So if looking forwards, then we're going to set the animation to front dash animation and the direction to 180. If it's backwards, we set the direction to 0. If we're moving to the right, it's 90. The left -90. And here we don't need, and this is the fallback value. If you don't move at all, it's going to be backdash animation, and the direction is already 0. This is the angles. And then we create an animation variable. we set the animation variable here, and then we play it. And then we use body velocity to move the character. It's deprecated, but it works the best for whatever reason. I tried using linear velocity, I tried using assembly, linear velocity, everything. It doesn't work as well as body velocity. We set the max force to vector3.new method huge, 0 method huge. We want the y to be 0 so that we don't move up or down. We set the parent to root part. We set the velocity to move direction.unit, which is where the character is moving, times dash force, which is here, how fast to dash. And the dash is already done. If we do game.debris, add item, the body velocity and dash duration, and then we do a task.delay to disconnect the connection if it exists. We do wait again, dash cooldown minus dash duration. We do this so we don't have to use two delays. We don't have to add in a task.delay, dash cooldown, because it's better to use as minimal delays as possible, as minimal threads as possible. So the reason why we're doing minus is because we already waited dash duration. We're not going to wait dash cooldown again, so it's going to be longer. So it has to minus the time that's already spent in waiting for the duration. I hope that makes sense. And then we can enable dash again. It already works. You can remove the comment here, but then you won't be able to move the direction. So to do that, we check if we're moving to the left or right. We spawn a function. So I got this idea to change direction from this guy. He made this really interesting code. I couldn't figure out how to make directional dashes on my own, so I used their forum. And his code works. But the thing is, it's really messy. Props to Mustang Devon for making a working dash script. But as you can see, it's messy right here. It uses spawn and while true do. It doesn't disconnect any function. It doesn't disconnect this while loop. It just checks if the character is dashing or not, which is a good way to create infinite memory leaks. It's bad. So I've decided to optimize it. There's a lot of unnecessary lines here, as you can see. So I've decided to optimize it by doing this. We spawn a function so that this function is in a different delay, and then we do ransom based heartbeat connect function instead of connection. So this runs every frame. So the reason why as you can see, it connects to a function, right? The reason why we didn't connect to function task.spawn and we put spawn outside of the connection is if we put task.spawn inside of the heartbeat, then it's going to be creating a lot of threads. We don't want that. This only creates threads once, and this creates threads a lot if you put it inside here. So okay, now let's get the camera position, which is camera X, camera Z, with Y as the root part position, as the root part Y, because camera is going to be higher than the character, so that's why we have to add in root part position Y. And then look, it's camera.cframe times camera.cframe 002, which makes this camera in front of the previous camera by 2 studs. And then we basically do the same thing here by setting the Y to root part Y. And then we use the camera position. And then we create a new C-frame using the camera position and the cam forward, which is the camera that's 2 studs forward. We set the dash C-frame to base C-frame times the angles, the Y angle to the direction, 90, minus 90. And then we set the velocity to that. Dash C-frame.loop vector minus dash force. Multiplied by dash force. So how does that work? So the reason why we're doing this, why we're doing this whole 2 studs thing, this is our head, this is our character, this is our camera, it's going to be above our character, and this is the variable, in which the camera position is forward by 2 studs. The reason we're doing this is so that we can get where the camera is looking at. This is the top-down perspective. So it's going to be looking forwards, right? And then if we multiply it with an angle, and then if we get the look vector, which is in front right here, we multiply it with an angle, it can move around depending on the angle. This is 90, this is 0, this is minus 90, this is minus 180. See? So we can't just do camera.position and then times dash force. It doesn't work because that's just the position of our camera. And then there we go, we get a working movement system. Dashing, it's working, it's cool. Dashing, running. Okay, this is it for this video. Thank you so much for watching. Next video, I don't know what to make. Maybe currency, maybe quests, maybe something, maybe classes, maybe NPCs. I don't know. Thank you for watching.